The last video I want to show you in this section that really you don't even need for this section, but you're going to need it really soon, and it kind of makes the most sense to me to introduce it right now so that when you see it later on, it'll make more sense. Throughout this section, we've been picturing a function with this kind of flowchart diagram where there's this machine and we take numbers and put it into the machine and other numbers come out. And one of the ways you can represent a machine is this standard notation. I could say that the machine's output for an input of x is x squared minus 2x minus 8. And so what we've been doing so far is taking numbers like, 0, and putting them into this machine and seeing what would come out the other end, -8 in this specific case. Well, in this video, I just want to switch things up a tiny little bit. All I want to do is change from putting numbers into this machine into putting expressions into this machine. Whoa, that's going to get super hard. It's really not. The whole purpose of this video is just to understand what this jumble of symbol means, and maybe you can compare it to this jumble of symbols down here. They look very similar, but they represent very different quantities. What this is asking me to do is, instead of putting 0 into this machine, put a plus h into this machine. How do I know I'm putting a plus h into the machine? Because the thing inside these parentheses here, the x in this case, represents the input into this machine. So just like earlier, when I changed that thing into a number like 0 or 2 or -5, I was giving you the input is either 0 or 2 or -5. Down here, when I change that thing into an a plus h, I'm telling you that the input is a plus h. You might wonder, why would you ever want to take a plus h and stick it into one of these machines? Well, frankly, right now you wouldn't. It wouldn't make any sense. But as early as 1.3, we'll see that this is actually super useful and something that we want to do. So since we'll need to be able to do it later, I want to introduce how to do it right now. But the good news is you don't have to worry about the why. All you need to do is understand the how. How would I evaluate f of a plus h? Well, it would be nice if it was the same thing I did to evaluate f of 0. Good news, it is. All you did, maybe reminder, the reason that f of 0 equals -8 is because I copied this blueprint and I changed all the x's into zeros. Why did I change them into zeros? Because 0 is the input. So to figure out the output that corresponds with the 0, I copy this blueprint where the input is an x. 0 squared equals 0. 2 times 0 equals 0. I got 0 minus 0 minus 8. 0 minus 8 is -8. The output of -8 corresponds with the input of 0. You're like, right, I got that when you beat that to death in the previous video. I'm not putting a 0 in, I'm putting an a plus h in. Well, how would you like this to work? Right? Wouldn't it be nice if I could just copy exactly what I see here, except change all the x's into a plus h's? Good news, that's exactly what you do. When the input is a plus h, the output is a plus h squared minus 2 times a plus h minus 8. That's it. This is the output. Okay, that's a little bit of a lie. You can simplify this. There's other ways you can write this output. But I don't want you to confuse the simplification with the concept of this is the output when the input is a plus h. Because it'll be beneficial to simplify this thing in future sections, I want to show you how to simplify it. To simplify a plus h squared, you have to think a plus h times a plus h. And maybe you were taught the acronym FOIL. A times a gives you a squared. A times h gives you ah. H times a gives you ah. And h times h gives you h squared. So a plus h squared is a squared plus 2 of these ah things plus h squared. So instead of writing a plus h squared here, I can copy a squared plus 2ah plus h squared. I can simplify this second term as well by taking this -2 and distributing it into the parentheses. So I get minus 2a minus 2h, and then I got my minus 8. But really all that does is it gives me a different way of writing the output. I'm going to call it the simplified way of writing the output, although the term simplified is kind of subjective. You might argue that this is simpler looking than this is here. But for the purposes that we'll use this in this class, we'll want this second form, which is why I'm going to call this simplified. But I don't want to confuse you too much. The point is just, instead of putting in numbers like 0 into these machines, by copying what you see here, changing all the x's into zeros, we could put expressions like a plus h, for example, into a machine. And all you do there is you change all the x's into a plus h's. To see if that made any sense, let's see if we can make sense of this. Evaluate f of a plus h. You're like, it's the same thing. No, it's not. Here, the input into the machine f is the letter a. Not the a plus h, just the a, because the a is inside the parentheses. So what I want to do is figure out what f of a is. Well, that's easy. I just copy what I see here, except I change all the x's into a's. So f of a would be equal to a squared minus 2a minus 8. And you're like, right, but that's not what the question asks. The question wants to know what is f of a plus h. Well, that's easy. The f of a is the a squared minus 2a minus 8 part, and the plus h is just plus h. You're like, wait, don't you have to put h into the machine? No, this is not f of a plus f of h, for example, in which case I would have to put the h into the machine. This is f of a. I'm putting a into the machine. And then after I do all that, I just tack on a plus h for this plus h right here. If you can see the difference between this answer in purple and these answers in blue, you really understand the notation, which is kind of the key thing that we're trying to understand when we're putting expressions into machines. I think I get it, but I'm not sure. Is there some question you can ask me that's like the hardest thing I'd possibly see with this that would really test my knowledge? Yep, here it is. Evaluate this mess. Maybe even pause the video at this point and see if you can evaluate this. Don't worry about simplifying, although I can tell you that if you simplify things perfectly, this h will end up canceling out. This is a hard question to evaluate this mess just to understand what it's asking. But if you can understand what it's asking, you understand everything that you should understand for this video. And if you're able to simplify this, kind of like I did up here, to the point where this h cancels out, then that's like extra credit stuff. Your algebraic skills are way beyond where they should be for this class. But since we'll need those algebraic skills in a couple of sections, I figure I might as well show you. So how would you do this thing? Well, the key thing is to notice that we have three different kind of parts, loosely speaking. There's this f of a plus h part, there's this f of a part, and then there's this h down in the bottom. Note that it's not f of h, so I'm not taking this h and putting it into my machine. My machine is still the same machine. I'll copy it down here for convenience. Really what's going on is I have questions inside questions. I want to figure out the orange question, then the green question, then the red question, then put those all together and see how this thing simplifies. Let's do it. First, we want f of a plus h. Well, good news, we've already figured that out. F of a plus h is what we did up here in part 1. We had two different answers, but I think I told you I prefer the second one. I call that more simplified. F of a plus h you'd get by changing all these x's into a plus h's, and if you simplify stuff, you'll get a squared plus 2ah plus h squared minus 2a minus 2h minus 8. What a mess. The good news is f of a is considerably easier to figure out. F of a, I just copy this blueprint, changing all the x's into a's. So f of a would just be a squared minus 2a minus 8. And even better news, the h is not f of h, it's just h. I don't put it inside a machine. The h is just an h. I can take these three parts and put those into this fraction. There's my f of a plus h. There's my f of a. Be careful with your parentheses. Make sure you subtract that entire f of a, hence these parentheses in brown, and then divided by h. If you could get this far, that's awesome. That's full credit. If you're interested in an extra credit, you might notice that you can get rid of these parentheses if I take this -1 that's implied here and distribute it through. I'd still have all the same stuff in orange, and then I would have minus a squared plus 2a plus 8 if I take this -1 and distribute it through the parentheses. And then I'm still dividing by this h right here. It's tempting to try to cancel out these h's or something, but you can't cancel out these h's. However, what you could do is recognize that I have a positive a squared up here and a negative a squared up here, and those do cancel. Similarly, I have a negative 2a right here and a positive 2a right here, so those will also cancel. And since I love canceling so much, there's a -8 here and a +8 here that'll cancel. When all the dust settles, I really only have 3 terms left up in the numerator. This plus 2ah right here, this h squared right here, and this minus 2h right here. And all of that stuff is divided by h. Now I can cancel out this h. Because each of the terms in the numerator has an h, I can take one of those h's from each of the terms and cancel it with this h. Or maybe it's easier to see it if you factor out an h from the 3 terms in the numerator. Convince yourself that the numerator here is the same as this expression here. Now I have h times all this stuff divided by h. This h and this h cancel. And what I'm left with as my final simplified answer is 2a plus h minus 2. For the purposes of this video, if you can evaluate orange, green, and red, you understand everything that you need to understand. And there's not really anything to do for red. If your algebraic skills are good enough to take those different pieces and put them all into one big expression and cancel out perfectly and factor and cancel again, that's really impressive. But if you're not there, I wouldn't worry about it too much. That's more like expert level. That's kind of extra credit for our class, whereas this is everything that I wanted to teach you for this video. I just wanted to show you how later on it'll be beneficial to not only be able to put numbers into these machines, but also expressions. And for reasons we'll learn later, the expression a plus h is a really useful expression to put into these machines.